Hello there, let's get started with CSS Flexbox. We'll start with getting started, then flex basis, flex direction, align items versus align content, and nesting flex divisions inside each other. I'm going to help you understand CSS Flexbox by showing you various demonstrations inside the Visual Studio Code Editor. I'll also be reappearing to introduce each new section, so let's get started. We know divisions by default are block elements, which means they display beneath each other or vertically. Now, just by changing the display property to flex, that'll make them display across the screen rather than displaying one beneath the other. The thing is though, that won't cause them to wrap onto the next line. If I drag this window over, you'll see them go off the right hand side of the screen. All we need to do is change the flex wrap property to wrap, and that'll fix it. Now we can also control the spacing by using the justify content property. We've got all these options in here. We've got space around, which causes space to appear on the left side, the right side and everywhere in between. We've got space between, which pushes the left and rightmost divisions to the side. And the other one that I often use is center, which causes them all to move over towards the middle. The flex wrap setting still works the same even though we're setting the justify content property to different values. For example, you'll still see that the divisions are clinging to the centre even though we're making them wrap onto the next line. Which brings us to the next property, flex grow, which we can use to stretch the divisions out horizontally to fill the extra space. I'll go into more detail about flex grow in the next section. But for now, if we take flex grow and place it directly within each of the division elements, we can play around with the values and cause each division to expand a different amount. This next section is all about flex basis, but also very much about flex grow, because I found them to be very closely related to each other. I am including a numerical example which involves using the Microsoft Edge Developer Tools extension. We'll use that to inspect the values, and that'll help us see how flex grow and flex basis are related and depend on each other. The first thing to notice is that if we set a flex basis value for each of the two boxes, it overrides the width value, but it won't override the max width value if you was to be using one of those, for example. Now for me, this is where it gets really interesting. I'm going to show you how flex basis and flex grow work together. We've got the flex container, which is 700 pixels available internal space, which is represented in green, and the width of box 1 and 2 are each determined by the text that they contain. Now if we set flex grow to 1 for each of the two boxes, they don't expand to an equal size as you might expect, because it looks like there's enough space to expand them to be the same size each. And that's because the share of available space that's given to each box in accordance with its flex grow value is added on to the initial size of the box. The development tools tells us that the computed value for box 1 is approximately 60 pixels, the computed value for box 2 is approximately 189 pixels, and so the available space is 700 pixels minus those two values added together, minus 4 times 10 pixel margins, minus 4 times 1 pixel borders, which leaves 407 pixels available for flex grow. We know that's going to get divided by 2 because each flex grow value is 1, so that's 203.5, and then by adding 203 onto the initial value of 60, we end up with 263 pixels for box 1 and 392 pixels for box 2. Now the default flex basis value is auto, but if we set that to 0, it then tells the browser to treat each box as if its initial width is 0. And then because each box is expanding from an initial width of 0, they expand the same amount. Alternatively, if instead of setting flex basis to 0, we give each box the same initial width value by using the width attribute, they then both expand to the same final value simply because they started out at the same value, just like when we set flex basis to 0. Now that brings us to flex shrink, which is basically the opposite of flex grow. The default value of flex shrink is 1, which means that it's always going to shrink as required, but if we set the value to 0, then it won't shrink, as you can see here. This is both boxes shrinking the same amount, and this is box 1 shrinking much less than box 2. The final thing to mention is that even though the flex grow values for all of the elements added together will typically exceed 1, so you could have relative values of 3, 5 and 7 for 3 different elements to form the ratios between them. The total amount of available space used can never exceed 100% of what's available. And you can also set FlexGrow values of less than 1 to give you fractional values of the available space, which can indeed total less than 100% of what's available. Flex direction basically means horizontal versus vertical, and we can change the default value of row, which by default means horizontal, to column, which means vertical. But by default I mean the writing mode is a horizontal writing mode. You can change the writing mode in CSS to be a vertical writing mode. Don't ask me what that means. Everything we've looked at so far is with the flex direction property set to the default value of row. Now, proceeding on the basis that the writing mode is horizontal, that means that when set to row, the flex direction is also horizontal, and when set to column, the flex direction is vertical, which also then means that flex grow occurs vertically, but flex wrap occurs horizontally into a new column. Now, align items versus align content. I spent ages googling the differences between those two, and to be honest it can be quite confusing. Basically, both properties make vertical alignment adjustments, but in an appreciably different way. The other thing to notice is that align content makes no difference unless at least one item has wrapped onto another line. The default value for align items is normal, and the default value for align content is stretch. There are various values for the align items property, including center, flex start, flex end and baseline. We've also got those same values for align content, but then also some additional values including space around, space between and space evenly. In this example, the available height is 500 pixels, minus 4x10 pixel margins, minus 4x3 pixel borders, which equals 448 pixels. Box 3, which is the tallest box on the first line, has a computed height of 234 pixels. Box 4, which is the tallest box on the second line, has a computed height of 214 pixels. Adding those two values together gives us the 448 available pixels. From here, we'll proceed starting with the default property values of normal for align items and stretch for align content, and we'll also leave the position property at the default value of static. Also keep in mind that both align items and align content are always both in play. Now, as an example, if we change align items from its default normal value, which for static layouts acts as stretch, to center, then the height of each box becomes minimized in accordance with its own line height property value, and all the boxes are aligned central to the given line. If we now set align items to flex start instead, then all the boxes are aligned flush at the start of the given line. Notice that up until now, align content's default stretch value has also been in play. For example, if we change align content to also be flex start, then the items on the second line are moved upwards against the items on the first line, which effectively is that the second line's start height position has been moved upwards. If we now change align items back to center, then once again all the items become central, but with align content still controlling how the boxes are spread out throughout the available height. Depending on the combination of align items and align content property values, it can be that one or the other makes no difference. For example, with align items set to center and align content set to stretch, if we now change align content to space around, it appears to have no effect. But if we change it to space evenly instead, then we can clearly see a difference. Finally, we can also use the align self property to align individual boxes. Nested flex directions. What I'm about to show you now, you can consider to be a CSS trick. How it works is that if you don't set a width value for the flexible divisions, then they'll only wrap onto a new line when the text inside no longer fits. But by setting a value for the width property, you're then controlling exactly when the wrapping occurs. We've got the pink box, which is a flex container, within which we've got the green box, which is also a flex container. Within that, we've got the individual divisions, the 4 divisions, which are boxes 1, 2, 3 and 4. we're allowing the green box to grow, and also the 4 boxes within the green box can also grow. When the green box is reduced to a width below 570 pixels, it's going to wrap onto the next row. When each of the individual 4 boxes reduces to a width less than 250 pixels, they're going to wrap onto the next row. So that's it for this tutorial. There's loads more to come. Hopefully you've found this one helpful. See you next time.